Okay, work in the digital creative industries. Nothing pulls you into the territory between art and science quite so quickly as design. It's a borderline where contradictions and tensions exist between the quantifiable and the poetic. It's a field between desire and necessity. Designers strive in those conditions, moving between land and water. I wanted to include this quote at the start because I think it's really fundamental to this idea that although science is quite an objective and a mathematical standardized subject, if we use it and use the idea of having data driven work that can be used to solve problems in a more poetical way and as an artistic input, it can actually lead to a really, really exciting field and a really, really broad spectrum of kind of like design philosophies and outcomes that really interest me. Okay, so prior to the coding diploma, on reflection upon my work, I was recognizing a juxtaposition between two kind of systems, so biological systems and artistic generation. So I was trying to create a synthesis of the two, which consisted of a process that's like observing and looking and seeing a biological process, and then thinking about how I can kind of take that process and manipulate it via physical replication to communicate an idea or generate a visual outcome. So it's a scientific stimuli, taking it, setting it up, and using it as a system within my own work to then develop its own outcome, which I try and monitor. This is also kind of shown in the diagram here, which is an MIT diagram from 2004 for their biodesign course. So it says discovery, which is the observation, definition, so natural phenomenon principles, kind of understanding it, seeing it, taking it, implementing it into your design and your idea, and then seeing the outcome and seeing if it works. So the prior case studies that I've chosen that kind of show that in my previous work is the first one is bacteria. So this is where I had a typographical project where I needed to create a typeface that aligned more with the content that it was describing. So the content was kind of about disease and DNA, and I thought, well, if I could take bacteria growth, which is a biological system, and I could somehow use it and shape it myself within a Petri dish to create letters, to create fonts. So this is shown here. And it's that idea of taking a natural analog system and using it as a generative device by manipulation of its shape to generate a device, a storytelling device. Similar in the case study 2, blueprints. So this project focused on texture generation. It's also my first time using a microscope, which as a designer I thought was great. So the scientific process of cyanotyping, which is a chemical reaction where light exposes a blue pigment and changes its colour. But if you use objects to block certain areas of the pigment, that doesn't change. So it creates like a two-tone piece of work. So using the microscope, I took very microscopic photos of monocoutes, which I then used to try and replicate and mimic into physical weaving and physical structures, which are then placed on a cyanotype paper. And again, use that idea of a generative system where I just left the weaving and the structures on the paper in random ways and let the way in which it works and it changes and reacts to the light to generate the outcome. So why I kind of went from that to thinking CCR would be good is this idea that my previous work did have an element of generative design, which I knew would be crucial to create a coding course. But what was different is that the generative design I'd worked on was completely analog. So it was setting up analog systems, letting them develop and change, and then taking the outcome. Whereas I really wanted to understand and try and develop the different skills and software that would allow me to try and take these biological systems and implement them digitally. So a good example of that is the differential growth system we got shown in the JavaScript unit, which is where a guy called Jason Webb observed and looked at the way in which cellular growth happens and then created a JavaScript algorithm that when you click play also works and splits and changes in the exact same way. Now, this is great because it can be implemented into 3D software, into modeling software, where you can create structures that mimic that and use it. And that's the exact type of thing that I want to try and work on. So my first case study is the PCOM, the drawing machine I created. So this was kind of like a visual manifestation of sound. So it's a generative drawer where sound was the generator and the variable that created the outcome. So this is the first kind of real switch in my use of generative design and generative systems, because instead of having like an analog growth that was the system, this is the first time where I've used data to drive the generator. So the sound would come in via the sensor, be converted to voltage, and then based on the voltage, would create various random outcomes. So this really introduced me to how, one, I can take external components, such as sensors, and use them to convert into data and drive machines and generate work. This is the first real time where data has been something that I've used as a driver to generate work or to inform my outcome. And that's really important because previously on my graphics course, I had no idea how to take data and use it as a stimuli. This led on to the second case study in the CCI course I'm going to choose, which is my piece, The Evolution of Man. So it's a physical computing unit, however, this time with the scientific element also brought back in. So I'd researched previously a lot into the use of mycelium and how mycelium could be used as a material of the future. However, I had struggled previously to grow it and develop it because I had no way to monitor the conditions that it needed or even read the conditions needed. But using my knowledge now of sensors and physical computing, I was basically able to set up an Arduino-based system that took in the temperature and humidity, the two most important factors for mycelium growth, and monitor what they were, and then use a water atomizer to develop and change the humidity and the temperature when needed. This was hugely great for me because it was kind of the first time where I was basically achieved what I wanted to achieve and use a generative system, because the mycelium growing, I still have kind of little actual hands-on ability to change, but using data-driven sensors, so the humidity and the temperature, I can actually adjust the speed and the rate at which it's going to grow. Furthermore, I was also able to develop my 3D printing and CAD skills to create a mold of my head, which I wanted the mycelium to grow inside of. So yeah, the future projects and research at CCI have really helped me look at the power of software and data for informing and shaping design. I'm also kind of looking at how I can develop these CAD skills and the environmental data to implement in my designs in the future. So 2 case studies that I've come across for studios that really inspire me. The first is one called Officiana Kopitskali, which is a research-based studio that looks at material futures, so non-human agents and how they can influence structures, culture, ecosystems, and human behavior. So one project they did recently called Bio Ex Machina was a piece where they adapted a 3D printer to be able to have a dual nozzle, one printed a mycelium substrate, the other printed the actual mushroom compound, and it created mycelium-based structures, which then grew and developed over time into a sturdy product. Now, to develop the structures, they used a piece of software called Grasshopper. So this is a brilliant example of how biology and computational skills can overlap, because Grasshopper is an algorithmic-led modeling software. And they used this to develop structures that they knew would be able to help facilitate and retain moisture for the mycelium growth. They describe it here as investigating the merge between digital algorithms, living agents, robotic behavior, and additive biofactoring, targeting the design of bespoke biofabricated furniture for interior elements. The second case study is biomorphogenesis. So this is more an architectural-based research studio that focuses on how algorithms can fabricate processes and develop new material systems that reduce material usage. So this kind of is the first time I came across the term biomimicry, which is interesting because if I think back to the prior case study to the blueprints, what I was actually doing here was a form of biomimicry, which is kept within a 2D environment. So I was taking 2D images of the structures of monochrotes and then recreating them using weaving and then applying it to a cyanotype. And then I kind of realised that actually is biomimicry. So they also, interestingly enough, use grasshopper as well. So they kind of use mathematical equations that they find in various different parts of nature. So the example I've shown here is the minimal surfaces known as a gyroid, which is inspired by butterfly wings and lipids. They worked out the algorithm for that, and then using Grasshopper, they implemented it into the 3D modeling software to create the structure, which was then much more material effective, didn't use unneeded material, and it's just generally much better. So based on both of these case studies, next year I think what's really vital to me is that I continue to develop my skills within 3D environment and especially understand how Grasshopper and how to use Grasshopper at a really high level. So luckily I've come across a really, really great book called Generative Algorithms using Zubin Kabatsi, who is basically the founder and the owner of Morphogenesism, the studio that I aspire to. And then following that and combining that with my knowledge of biocompounds and material efficiency, I'm hoping that I can basically work on either a 3D printer that is able to kind of like mimic and copy biological structures, or also go even further and use a 3D printer that actually deposits and 3D prints my own source of biomaterial and uses Grasshopper to grow that into a structure that facilitates the growth. Thank you very much.